Okay. Where was I? Yes. So beyond uh, types, this is a common sentiment in not only the Rust community, but other languages like Haskell, I guess Scala, that if you get your types right, your program is more likely to be correct. A lot of people, I think, kind of ride the hype train too much, and they make claims like, "Oh, if you write the types right, then if it's composite, it's gonna work." Uh, I think this is actually a good type of hype because it's something that we should all aspire to. Like, we should engineer a tool so this becomes true. It's not true yet, but
like lean.
yeah, exactly, like lean. So we should. This is a worthy cause. We should work on it, and a big part of that is specification. If we manage to pin down how we write specifications for Rust that are that can express properties going beyond just the type system, then we're on our way to this goal. Okay, so a little bit about Varus. You can check it out. It's on GitHub. It's an open community project. A lot of people contribute. I would say the center of mass is somewhere between CMU and probably Microsoft Research. It is a dialect of Rust, which means it has extensions that allow you to write specifications in your Rust code. It feels like very native. And its main backend is Z3 at the moment, but I think people are working on making it work with other SMT solvers. It has a pretty mature toolchain. Uh, I put a lot of effort in the toolchain itself, so that's my main area. And it also already has users inside of companies like AWS, Microsoft. Um, and like I said before, a lot of my inspiration for Anodized is coming from working on Varus and seeing the challenges. So I'm going to focus on two different sort of points of view when I talk about these obstacles. There are end user pain points that hinder adoption of the system itself. And then there are tool dev pain points that hinder development of the tool itself. And both of these are important. Obviously, you all are in the tool dev camp over here. But I'm also going to talk a little bit about the end user pain points because obviously we all want these tools to be widely adopted, and if we don't engineer them to be easy to use, then adoption is just not going to happen. All right, so the end user pain points that I think we should focus on is that learning a new language or even just a new dialect of Rust to write specs is difficult. A lot of people see that as friction. So if we can make something where this doesn't need to happen because it's using a language that they already know, then that's the best case. And then another sort of side issue or side to this coin is keeping specs and implementation in sync is the same sort of problem as, I don't know, keeping code and comments in sync. So if we have a system that kind of makes this problem go away, it's great. Uh, People don't know how to choose a system upfront. Um, so this is kind of related to the last point, which is migrating between incompatible systems is costly. So if we can make all these systems compatible with each other, it lowers not only the migration cost, but also kind of alleviates people's fears that if I choose the wrong system up front, I'm not going to be able to switch to another one. So a lot of people, before they commit to writing specifications in their code, they are afraid that they're going to put in all this work and then they'll discover that either because they chose the wrong system or some other reason, that's going to be a lost effort. Okay, and uh, very briefly, but I'm sure you are all familiar with this perspective, the tool dev pain points, which are integrating with Rust is just not easy. In fact, the internals of the Rust compiler are deliberately kept private, so there's no real public API. There's obviously like you can make a Rust C driver, but even that is not without pain. And uh, on this, like a similar note, owning even just a dialect of Rust, even if it's not like a full-blown language, has high engineering costs and maintenance costs. This often involves forking things like either rustc or maintaining a rustc driver, forking syn so that there can be tools that integrate with your system to parse syntax, forking cargo so that you can integrate with the toolchain, forking Rust analyzer. So when people use your language, they get some sort of IDE integration in their editor of choice. All of this is doable, and in fact, I know what this looks like doing this on Varus, where Varus basically chose to do all of these things. So there's like Varus Syn, there's a Cargo Varus plugin, there's a Varus analyzer, and so on and so forth. But it is very costly from an engineering perspective, and it's slowing development down. So I'm hoping that Anodize could become a system that would be able to save people most, if not all, of this work. All right, and informed by what was on the previous slides, these are Anodized goals. So it wants to maximize ergonomics on stable Rust. It's very important. Most Rust developers want to use stable Rust. So our goal is to make things work on stable Rust. Use Rust as a spec language. Obviously, Rust is the language that every Rust developer already knows. So by enabling them to write specifications in Rust itself, they don't need to learn another language. The friction is minimal. Obviously, there are little quirks in there that we have to watch out for, like not every element of logic is trivial to embed into Rust. If we're only talking about like predicates and booleans, it's easy because we can just say there are bool expressions, but as soon as we want, let's say, quantifiers, it's not simple anymore. All that is to say is just not trivial. And then we want to integrate with existing tools as much as possible, whether these tools are Aeneas, Lean, Hex, or other as well. An exciting development here that I've been paying attention to is there's a system called Hegel. It's a property-based testing system where there's basically a server that is responsible for understanding preconditions and generating valid inputs, and then driving whatever function needs to be driven, checking postconditions, and if it discovers that the postconditions are violated, then it also shrinks the input. And Anodized could easily integrate with a system like that to get basically property-based testing for free for pieces of code that are annotated with specs. And we already have runtime checks, by the way. So that's the main thing that you get if you just add Anodize specifications in your code. We're also being careful so that there's a feature setting that guarantees that these runtime checks are all stripped away in your production code. And that's basically it. What I want to do next is just show you a few examples of what these annotations look like, and I intend to make this fully interactive. So please feel free to ask questions. Anything that comes to mind, just stop me, and I'm happy to go as deep into the bellows of Anodize or more examples.
Yep. So you worked with Varus and Anodize. What are the main differences in the spec language used to? That and for instance, like one big question I have is how much more powerful is Anodize spec language compared to Varus? Using some dependent type theory?
Good question. I would not say it's that it's more powerful. I think it's probably true that Varus at the moment is more powerful because it supports out of the box things like unbounded integers, and it also distinguishes these tiers of you have like ghost code, proof code, all this stuff, right? And Anodize doesn't have any of this distinction. So all the code that you're writing in specs is just normal Rust code, which obviously has the downside that if you want, let's say, unbounded integers, you have to bring your own library. Or Anodize theoretically could supply one, but it's not on the roadmap at this point. And the main difference is that, like I said, Varus is a dialect of Rust in the sense that it's extended. So people who just want to be on standard Rust, they can't use various. They can use anodized. So anodized works with normal vanilla Rust. It doesn't assume anything about your toolchain. If you want to use various, but you're not really knowledgeable about formal verification, you're probably going to have a hard time installing things like Z3. My understanding is at the moment you have to like build that from source. There are other tools involved, and it's obviously, it just means it's no longer just the Rust tool chain that people are familiar with. And Anodize avoids this, like sidesteps this issue completely by targeting standard Rust. Yep.
You're aware of the tool that is called Tracy.
I've heard the name, but I'm not sure.
Where you also annotate the Rust code with information like spec-like things that are linked with Markdown specs files. And I think that would also be an interesting direction to plug and anodize with that.
Thanks for the comment.
Actually, the follow-up question to that: do you generate documentation? So, like, does this integrate with RustDoc? Okay.
Nope, not at the moment.
Yeah. Could be an easy, I think, because like, this is a like an annotation that's allowed, like the proc-macro that you write is allowed to change the AST, right?
Yep.
So you could okay. Yeah. Cool.
Okay. Can you all see that? Maybe I'll make it a little bit bigger.
If we integrate it with Hax or Aeneas, we could also have the status of the spec somewhere.
What do you mean the status of the spec?
Is it proven actually? So
Yeah.
every spec will generate a theorem, and some of them are proven somewhere. Sorry. So you get the status as well. So
like in the RustDoc, you mean?
Either in the Rust or in the report that you build.
Right.
You
Yeah.
get the specs extracted from the code, so you know it's correct. It's the same at least, and then you know the status.
Yeah.
Okay, so this is an example of a spec annotation using Anodize. As you can see, you're just importing spec from Anodize. That's pretty straightforward. And then the spec itself has parameters or sections like requires, which are the preconditions, ensures the postconditions. There's more stuff in here that I'll go over in the following slides. This is basically it. And these conditions or just standard Rust Boolean expressions. So one benefit of that is you basically get normal editor integration. So I did not have to do anything to get the standard Rust Analyzer VS Code plugin working with this, for example. So I get the tooltips.
Is that out of the box, or did you have to like teach it about
this out of the box? I did not do anything for it to work this way.
If I just like didn't even have, let's say that you didn't, that plugin was invalid or whatever, would it still work, or is it just like as long as the spec thing exists as a macro, then Rust Analyzer will try to read the inners of it?
Yep.
Wow, very cool.
To go a little bit into details, here is the thing that you need to be careful for when building the macro is that you need to propagate span information. So this is what this mechanism depends on, that when you get a failure, the Rust compiler, obviously the failure happens in like the expanded code, like the code after macro expansion, which is like really ugly. People don't want to read that. If you've ever used C++ with templates, sometimes you get the 20 pages of errors in template code, and you have to figure out like where it is. So the way Rust prevents that is by being able to map back errors from the expanded code into the pre-expanded, like the code before macro expansion, and basically showing you like this error is coming from this macro over here. And by being just disciplined and following these guidelines of how the proc-macro should be written, you get this automatically out of the box. Sometimes it makes things tricky. So like I said, you have to be careful when you develop the macro, but otherwise, when you follow all these guidelines, it just works.
Is this being desugared into something where there's basically just like each of these is getting injected into the function body or something like that? Okay.
That's right. So now that we're talking about this, I'm going to briefly explain like why this works, like why you get errors at all. So it's but first like a little demonstration. So if I let's say I can say like let's rename this symbol to LOL and it will rename it here, here, and here too, right? Or I can say like take me to the definition. Obviously it knows it's there, but if I mess it up, like if I say like if seek is, I don't know, smaller than blah, which obviously it makes no sense because this is a string, it will say like this just doesn't work. Right? So the reason why this works is what whoops, Josh was just getting into, that there's a piece of instrumentation. So what the macro does is when the macro gets expanded, it basically injects small pieces of code into the body of this function, so that, for example, when you're running with runtime checks enabled, all your preconditions are going to become asserts that sit at the top of the function body, and all the postconditions are going to be turned into assertions that sit at the bottom. Well, notionally, because you might. So it's a little more involved in this because you can have like early returns in the function body, for example, and you just have to deal with it. But that's basically how it works. And the postconditions, it's not apparent from here, but I'll show an example in a bit. These are basically closures that take the function's output by reference. So they can inspect it. And so this is how you get runtime checks, right? If you don't want runtime checks, the kind of insight is that it's easy to turn them on by surrounding all these assertions with some expression that will evaluate essentially if false. And then that code eliminator will eat all this stuff. But by the time all this code gets to the dead code elimination phase, it has already gone through syntax and type checking. So you get these nice error messages, even if it has no runtime cost at all. Question?
One thing we have in Hax postcondition is to talk about the initial value of an argument that is mutable and also the final value. Do you have a way of representing that?
Yep, in a couple of slides. Let's not get ahead of ourselves. Any more questions about this?
I have a question around how this would look like in Varus, but I'm happy to wait until later on.
I can just briefly explain. Like the main way Varus differs is because they really extended Rust, is these things end up here. So you know how in Rust, like sometimes you have like a where like section here. So they basically make it look like that, and it looks like ensures. Sorry, requires ensures, and then those are just in there like that. So it would basically look something like this in Varus, and
because then Varus can also translate that to Lean. I remember Brian telling me they were working on Lean back in.
Yep.
Right.
So that's the main difference, that this looks somewhat nicer. It looks native. Before I forget to mention this, so people in the Rust core team have an initiative to make these sort of contract annotations native to Rust, but it's going very slowly. Unfortunately, the person who could tell us more about that is sick today, so he can't be here. It's not real.
Oh,
Yeah.
Where was I?
I have to go, but we're gonna set later, and we're gonna talk.
See you in a sec.
Yeah.
Okay, so we can just, all right, before I forget. So I initially started working on Anodized because there's another Rust crate called contracts that can basically do something like this. It doesn't look nice, like every requires and ensures has to be like a separate macro, but you can make it work. And my main beef with it was that as soon as you put a to-do in the function body, the contracts crate just completely fails with a compile error. And I often do this style of programming where I leave holes everywhere in my program, just to-dos. And when execution hits that, it will tell me now you need to implement this function, or the large language model that I work with will implement that function. So I actually, this was the first thing I made sure when developing Anodize that this works. All right. I think I can't do this demo now because I'm on the, but let's just try anyway. So one fun thing that I like trying is taking a function with an empty body and the elaborate type signature and spec and throwing it to a large language model. And seeing what it does. Okay. Let's see if this is at least typed correct. Yep. So now the problem is we don't know if it's actually correct. And if I don't want to understand, it would be amazing if I could just run some sort of tool like a verifier that would tell me whether this implementation fulfills the spec. And that's kind of the goal that I want to work towards. Okay, here's a somewhat simpler one. We want to compute the percentage of from two floats, basically a nominator and a denominator. We would have these sort of requires preconditions. And this is what I was referring to earlier, that the postcondition is actually every postcondition is a closure that takes the function's output. And there's a shorthand, so I can delete this part, and it still means the same thing, and the default name is output. But let's say if I had a function argument that is called output, then I don't want the name collision in there, then I could say something like return value. And that works too. Because it's a normal closure, you can also use patterns to destructure the return value and so on and so forth. So let's look at something more complex. By the way, these examples, I gave a talk at the Tokyo Rust meetup, and obviously those people are not experts on formal verification. So sorry about these examples being like very trivial. Let's trivial. So we're sorting a slice of two ints here. And so now we can express that we want the output to be sorted. And we also need to specify that the output is either the input or the input with the two items swapped. That's pretty straightforward. This is somewhat annoying that the preconditions take the output by reference, but I think it's something we can live with, and Rust programmers already have to deal with situations with references. So it's not unusual, and it's a small price to pay for just being able to do runtime checks out of the box, for example. What's the price? That sometimes you have to dereference.
Oh, sure.
Because
yeah,
it's like minor ugliness. Okay, so somewhat like next improvement is the spec annotation supports this binds parameter where you can list a pattern, and this pattern is going to override the default argument binding for all the post conditions. So now you can just write the ordering post condition like this, and then you can also rewrite this part if you want. Basically makes it easier to see what's going on. And because it's a normal Rust pattern, we're here. you can also reintroduce the alias. So now you can simplify that too. And now we're gonna get to your question, which is how do we deal with situations where this input items is a mutable slice and we want to sort it in place? Then we have to remember what the old items were. So we can say like now the output is either old items or old items with the items swapped. And the way we do that, so there's alternatives here. One alternative that the contract script uses, for example, is it has what they call a pseudo function by the name of old. So it would say like old and then pretending it's like function call old of items. I didn't like that, mostly because it involves rewriting postconditions, rewriting expressions, and all the error reporting and stuff works much better if I just treat these as opaque blocks of blob code in the macro machinery. So I really wanted to avoid that. And I came up with this where you basically say captures, you list some expression that you want to capture, and then you can introduce a name. You can omit this, by the way. So if you don't list this name, then the left side has to be a simple identifier. So then you can't have like function calls or whatever. And then it will just automatically introduce like old underscore, whatever the name was. But this is like the full form. So we're capturing items and we need to clone them. There's many reasons for that. Why it's better to do it this way to make the clone explicit. One is that if this were to be a copy type, then you would not have to use a clone. But also another sort of convenient aspect of this is you could introduce some sort of method on whatever this type is that you only use in tests, specifically for this purpose of making like deep copies of whatever state is there that you care about when you're testing pre or post conditions. So, right, like now we have this old items and it's just available in post conditions like that. And as you can probably guess, what we're going to do next is we're going to allow patterns here too. So now we can deconstruct it right here, and these become easier to write. Any questions about this? All right. Now we're just going crazy. Like we can reintroduce the alias.
Just a remark. So we had kind of a similar mechanism with Hax annotations, but for historical reasons, we consider the future value rather than the old value. And it was made with a function call. So every time you have an argument, let's say here it's items, you could do future of items to get the value at the end of the call.
Interesting.
Nice way as well.
So it's like as in future, as if it were a function call, like future of items.
Future of, yeah.
How do you deal with the collisions there? Do you just assume they don't happen? Or?
Like there's a thing.
Like let's say if there's there's a scope of future in.
I don't remember that.
Gotcha. Okay. What was I gonna say? Yeah, this is not super exciting. And then we can move to sorting. So I guess the main point here is you can create your own like testing machinery that's just arbitrary Rust code, and you can use it in your specs. And I think it's likely true that tools like Aeneas can already deal with this because they know how to transcribe Rust code into Lean. So you kind of get that for free.
What is the config test? Like, are you parsing that attribute yourself, or is that pre-parsed?
Good question. I did not notice that I had it in there. So what is that? I'm parsing this in the macro. And the purpose of this is, let's say some check, some post condition or whatever is expensive. So you actually don't want to, even though you have runtime checks enabled, even in your release build, you don't want to run it all the time. You only want to run this in test configurations. And this tells the macro machinery only inject the instrumentation guarded by
Yeah,
this
you do it
TFG
verbatim.
plug. Yep. So I just
Yeah.
propagate like whatever setting you have in here. One extension that I'm already aware of that we'll need to make to Anodize to make it more widely applicable, talking with Maxime, is that it should be able to retain arbitrary attributes in spec parameters and just propagate them, surface them to the extension API. That is currently not happening, but it should not be hard to affect that change. Right now, the only thing that it understands is this CFG.
Typically, you could have
Stuff.
a set of specs for panic freedom,
Mhm.
and you could have a more advanced specs for like functional correctness.
Right. Yeah.
And so those would be guarded by different attributes.
Uh-huh.
Yep.
And depending what you do with the spec, you be interested in some of them or all of them.
Yeah.
Another thing that surfaced is we should probably have either like a separate section in the spec or just attributes that you can use to configure options for a specific backend, like Hax or Aeneas, propagate like, I don't know, or limit parameter, this sort of stuff.
We also have backends for both smart contracts and for, some symbolic crypto for ProVerif. Connected to Hex. So I think they will fit in your framework, but that would be very nice to test out.
And also default spec like panic freedom. This kind of stuff, those are default spec that could be interesting.
Shall we go deeper into this, or let me hide this again? Right. I'll just pull up my roadmap real quick. So one thing I have not shown yet, but it's already in and working. I was showing plain functions. Obviously, functions inside a native impl also works. You can also put impls. Sorry, you can also constrain trait functions or methods with pre and post conditions. And one thing that I'm considering as an addition is to be able to put these specs on modules, where you would be able to express constraints on interactions of multiple entities inside a module. I don't know how useful that is, but we can certainly make that happen. And then I know that for Hex, for example, these are important, like while and for loop.
Yeah, about traits. So maybe this is a question we can take for later. But so with your macro on the trait definition, you will insert some checks on every input. So how do you do that? Like the macro will change something that's out of its scope in a way.
It piggybacks on default implementations. So the trick is to put the spec on the default implementation that is forwarding the call to a hidden or like user inaccessible method that's at the moment the identifier is underscore anodized underscore whatever the original thing was. We make it purposefully ugly that if you're calling it, you know that you're doing something that you're probably not supposed to. And because of this forwarding, then when you're implementing a trait, that also gets transformed. So your implementation is actually implementing this ugly like underscore thing that the default implementation is forwarding to. So then because the default implementation carries the spec, like the injected checks, it's always there. There's no way to avoid it. These checks are runtime checks, but it means if we had the backend that is I don't know, emitting hidden functions for a tool like Hex or Aeneas to produce, they would also be there.
Because one thing you could consider, this wouldn't handle everything, is if you put those assertions inside of a const block, then they'll fail compilation. So you could, for the things that are for the assertions that are compatible with const execution.
Sometimes the properties depend on inputs and stuff that you don't know at compile time. So I guess that's like a weakness. Yeah, that kind of stuff. Or another shortcoming that we currently have is we simply don't allow additional specs on the methods of a trait implementation. The concern there was that we would have to confirm somehow that the it's a proper narrowing of the properties on the trait itself, and we would need a logic engine for that. And when you're doing runtime checks, you just don't have that. So
could you not just
the
like,
safe,
execute both of the checks,
like
both sets or something?
We could, yeah, that's a good idea.
If you extract towards some proof assistant through Hax, you'll get just another proof obligation. So that's something we did with F-star, the F-star backend speaking.
Very good. Do I want to talk about anything else?
You just added quantifiers.
I can show one. Yes, that's a good point. I'll pull that up real quick. They look like this. So for example, you can write, so this is a Boolean expression, and you can put the predicate as a big closure in it that can basically do arbitrary stuff. And it was a little ugly to make it work. So it doesn't work with arbitrary like input or parameter lists. It works up to a count of 5. And I can just easily add more. Currently, this is all handwritten stuff. Somewhat ugly. It looks like this. And we would have to continue this pattern to allow higher arities. The Rust standard library itself is full of these kind of patterns because there's no generics for tupularity. But yeah, so then if you want quantifiers, now you can recognize these quantifiers in when you're consuming the specs from Anodize, and you can translate these into whatever structure you want on the lean side. What else is missing?
That would be extremely nice. I don't know how hard it is that some for rows are actually computable. If it's for row on an array, then you could do it at runtime. And some are like there's no way it's for row on U62 or 64. So having maybe, I don't know, some type class layer that would say, oh, those kind of for rows you can execute them, those one you cannot. Could also be a nice.
You would write it differently if you want to for all the values of an array.
Well, you could even imagine like a right, if your quantifiers are predicates or objects themselves, right, they're functions or something like that, you could imagine just having a another type which is like executable up, right, and that just indicates, hey, you should actually try to execute this, right, so the user could just tell you like this one I want actually executed or something like that.
I was even thinking like you have a for all that depends on the type parameter, and if it's u something or I something, then the thing won't be executable. But if it's an array, then
but when you usually with Hax, when we were writing a lot of these properties for all values of an array, and we were writing for all index I u size. If I is under the length of the arrays, then this property holds on the array.
In that case, it's not executable.
So you need a better way to write properties on all the values of an array, which could be like a different for. Or well, in Rust, the natural way would be to array.iter.all.
Yes. Or .any for exists. Yep. Yeah, good point.
Are there some examples of things that you have found difficult to tackle, like in principle, in this model? Or like it's like you've got this basic model and you said, okay, it's a very natural way to like add support for this and add support for that, and so you've got this like laundry list of features. I'm just wondering, are there any things where you've like either thought about or even tried to implement and you go, oh, I like don't know how I would encode that in this model?
One sticky issue, it's more like an implementation thing, is currently the features are mutually exclusive. So if you try to use this here, you're gonna get this error if you don't have a feature selected or you have more than one of these runtime features selected, where we support things like runtime check and panic. It's supposed to be the default. There's also runtime check and print, where it just prints that some violation was detected, but it doesn't actually panic. And then this is the one that just strips everything. And the problem with this way of hashing it is that Cargo expects features to basically be completely orthogonal, like settings, like bits, flags, or whatever, and it just breaks that. So this came up somewhere where Cargo will just run with features all, and that will obviously fail on this. So there's a need to refactor these features and somehow make them into options that are orthogonal. That's one. Again, if we add more backends, it's not immediately obvious to me, like what's the right way of doing that.
Yeah.
Like if we want like a specific backend for Aeneas or Hax,
right.
we'd have to come with that.
No check and check, it's not really compatible.
Yeah, I mean, usually what the cargo way would be to say that check is the feature and you can either enable it or disable it.
Yep. So I have like check and then have another one that says like panic, and I have another one that says print or whatever. And then I guess, yeah. Oh, these just don't make sense, these combinations, but.
Have you run into any issues with the design choice of having this be a proc-macro?
Yeah, a lot actually. So you have very little information inside the proc-macro. You don't have type information, for example. So you can't really rely on even simple things that you think you should be able to do, but you can't. That's a good example of this.
What are some examples of type information that you would want to be able to extract? And actually, sorry, like that question, and then a sub bullet to that is, do you need that information at the execution time of the proc macro, or do you like in principle, if you could like have it as a const or something in the generated code, that would be sufficient?
Let me tackle this first question first. So going back to, I guess I don't have it open anymore, huh? Yeah, okay. So not gonna, let me see if I can find it in the examples. Okay, so for example, one thing you could sometimes imagine doing is make this less ugly. So if you know that the output type is copy, which it is in this case, then you could forget about making the argument of the postcondition checking closure reference. And that would allow people to like write this in a more sane way, but because you don't have the type information, you can't. So then the answer is just make it a reference, and that's one thing. Sorry, what was your second question?
I'm wondering whether there are any things where you only need the information about the type to be accessible to the code that you generate, not actually accessible at proc macro.
I can't think of an example of that. Another thing that comes up is when you're instrumenting or you're putting these specs on a trait. It would be really, sorry, not the trait. So let me go back to the roadmap. So there's this idea that you could put a spec on data structures. So you would be able to say, I have, I don't know, I have a vec that is never empty. So you could create like a new type pattern that says non-empty vec or whatever, obviously wraps a vec, and you put a spec on it that will say something like maintains vec.length is larger than 0. To make this work, it would be easy to make this work if you could, in the macro, you could inspect and you could ask like, is this type implementing a trait? Because then you would be able to introduce a trait that says I have these some sort of invariant. So anything that has like a anodized invariant would implement that trait with all the like the checking function inside or whatever. And then you'll be able to call that, except this information is not available in the proc macro. So this doesn't work. And at this point, I'm not exactly sure how I would implement this.
You said, just as a point of detail, you said maintains. Is that one of your keywords, or you just use?
Yes, I forgot about this, but I guess I'll show a more detailed example at the bottom here. So you can say things like this, maintains. So it's this condition is shorthand for having this condition as both a precondition and a postcondition. So you don't have to write it once, and then this is called maintains. And I imagine if we were to put spec annotations on loops, for example, then this would be the loop invariant. It would also be called maintains.
What do you do? You realize I haven't even asked about this in general. Do you have type and, well, you said you have trait invariants. Do you have type invariants, like, this field satisfies the predicate at all times, that sort of thing?
Not yet, because I'm not sure how to implement it, precisely because of this lack of type information in the proc macro.
Okay, interesting. Yeah. Huh.
I wonder if it's a separate question to how to get it to work as a runtime check and how to get it to work as a proof obligation.
Yeah, absolutely. I think
we were kind of talking about that with Maxime half an hour ago about we want to include it as a dependent type, we want to include it as separate proof obligations that appear from time to time. But yeah, there's also interesting stuff there, I think.
That's a good point. I think for like proof obligations, for some sort of static checking, we have way more freedom. Precisely because we can just do what you guys already do in Hax of just emitting invisible functions, or like you said, like const, like hidden const, static const things that some backend can parse out, but it's otherwise invisible.
Can you say a little bit more about why, like, as you said, it's difficult to figure out how to encode or thread through the type level invariants? Give a sense of where the difficulty is.
So when you're inside the proc macro, let me track to some example. I guess I don't have a single example where you have a body, but you can just imagine that. So when this macro invocation is being expanded, the whatever piece of code that you wrote implements the spec macro is fed the syntax of this thing. Because it's called like a token tree or something like that. But it is really just a bunch of tokens. Yeah, so we'll say like keyword fn, and then identifier, calculate even result, open parent, or like a span that has like open closed parenthesis, and then on the inside you have I don't know, probably identifier and then punctuation, so on and so forth. So you often can't even tell whether something like an identifier is in a position where it's supposed to be the name of a type or the name of a non-type level entity. You already don't have this information. So it only gets worse from there.
There's one thing that we do in Anil, and we have the benefit of being able, because we operate on the LLDC, we can sort of like we do whole program analysis, or at least we can. And I'm curious whether you could, maybe you'd need module level. You can imagine different ways of doing this. Is we basically just assume that every single argument has a validity predicate. It's just that by default it's going to be, like some default value or whatever. And we emit, a requirement on every single, function entry and exit. I wonder if you could do something similar where you just like.
So the kind of trump card solution, and this is in fact what Varus does under the hood, is you basically put, instead of putting your machinery into the proc-macro that is processing this annotation, you leave this be as basically a no-op, and you have another macro in Varus. It's just called Varus bang. Yeah, that eats like a giant span of code. And in Varus, you usually stick your entire module in it. And then now that has the visibility of everything, but then it also carries the burden of like parsing everything, like basically reproducing the behavior of the Rust compiler.
Yeah. I mean, even there, it's not fully sound unless all of your fields are private, right? Because you could like mug with it outside the mod.
So I think a next step here to figure out how to integrate with something like Hax or Aeneas, for example, is to settle on, like agree on a way of representing these things in either transformed code, or I'll just show you. I didn't show this part. This is not like super complicated. So if I go on,
You need to be able to match the pre and post condition with the function to write the theorem, this kind of stuff.
When you say match it with the function, what do you
So the precondition, if I understand correctly, at least what we did with Axe is the precondition and the post condition that you saw are extracted as separate items with a separate name and so on. And in the big output we get from our engine, whether it's Axe or Aeneas, you have to know that, those two items are not proper functions. Those are pre and post linked with that other function there. And so we need to like take them and create the theorem stating the right thing about the function.
Yeah.
So we had a mechanism with unique identifiers that was a bit cumbersome, but worked. So
sure, yeah.
And I think there's some engineering, but it should be okay.
So this already exists, where we basically expose the data structures that Anodize uses internally that piggyback on SYN. So
yeah, that's the
if you execute
to extend and
yeah, pretty much. So if you want to tap into this, this is already available, so you can run your own parser that finds the spec annotations, and then you know exactly where they are, and this still gives you the ability of not having to rewrite that parser yourself.
So technically, we write probably one theorem for every spec we encounter, something like that.
Sorry, come again?
We'll write one theorem for every spec object we encounter.
I'm not. I honestly don't know.
Annotation would be a theorem that states the preconditions named in this spec imply the postconditions named in this spec. So that'd be a single. Is that what you're saying?
Yeah.
Yeah.
You have the.
Well, first we would need to. So this is available to extend Anodize. So first we need to extend Anodize to expose that in the Rust code, right?
Well, yeah,
you can already use this. So, for example, you can import the SYN crate. The SYN crate has machinery that, it basically implements the visitor pattern for Rust code. So then you can use that, and you can write a visitor that will visit all proc-macro invocations. So you can find the ones that are calling anodized spec, and then you can import this anodized core crate, and that allows you to parse out the payload of these spec annotations that you found. And then now you basically have Rust code that you can do whatever with.
If you have code that uses Anodize for annotation and you pass it with SYN, is that right?
Yep.
So SYN is
that's not what we do in Hax.
Yeah, I understand. I'm just saying that this is already open, and it is painful, but this is already possible.
what is the how do you extract that from that?
Basically, we use the macro expansion to generate those extra items. So we feed that to the engine that will produce either a star or something else. And then after the engine has translated the code, we'll do the patching of saying, oh, but actually those two functions were not real functions; they were pre-imposed, and we have to link them with that.
Do you have a tool? So like, if I'm actually interacting with Hax, am I running like cargo Hax or something on the command line?
Cargo Hax into lean, cargo Hax into a star.
Okay.
Integrates with REST-C, so REST-C does all the parsing.
Right. The reason that I'm asking is that if you already have a command line thing and you're not right, so like zero copy, for example, we promise that if you use normal cargo, it will work. So it wouldn't work if you did that. But given that you already have your own top level command that is the entry point, it would be relatively straightforward. In fact, Anil currently does this. I'm planning on getting away from it. But it would be relatively easy to just discover all the .rs files and then pass them through SYN to get an abstract syntax tree, and then use anodized core to like. It would not be much work for you to like hook into this.
Yeah.
Maybe.
So
That means we need to parse the files twice, like once with our normal toolchain using REST-C, and once with
Yes, that is how literally every proc-macro works. And I don't mean to say like it's. I just mean like everyone is used to accepting that cost already, so like it would not be that big of a deal, honestly. Like this is how, for example, like zero copy, right? Rust parses your code once, and then zero copy parses it again, and that's just how the fucking ecosystem works. And if you have multiple derives, like if you have, let's say you have like 5 derives on your type is getting parsed 5 times, and that's just like people are kind of just okay with it.
But that's part of a macro, right?
Well, my point is that like the idea of doing multiple passes over some set of source code is already a cost that is accepted by the ecosystem.
I don't care about the performance. It's just about the engineering to like.
yeah, not having to re-implement the parsing and type checking and all that.
Yeah, and also if you do it twice with different ways, there's always a risk of they're not doing the same thing exactly, and so
technically
cases are not treated exactly the same.
That's technically true. It depends on the level of guarantee that you want. I will say all of the like, including zero copy, right? All the crates that like promise like we're doing really careful whatever. We all use SYN as our cursor, and so it's like that doesn't mean that it's correct. It just means that that's sort of like everyone accepts that that's the bar.
Yeah.
It also
otherwise we could like call the proc-macro on top of the call to the anodized proc-macro, and then like do some.
I mean, to be clear, like if you're worried about going to that level, I am aware of at least 3 different ways that I could break Hax today just by like tricking it into parsing something incorrectly, because it's like a fundamental problem in Rust. Like where like you could do this with zero copy, where you like I can get it offline, I can give you the details, but the point is like it's already the case that I can write a program that compiles just fine, and all the proc macros, like including the Hax proc macros, eat the syntax tree in the correct way, and then the syntax tree gets modified before it's actually compiled by Rust. So you read in some syntax, and then that's not the syntax that actually got compiled. So it's like and there are like multiple ways to make this happen, and it's a fucking nightmare.
I think that I think it's a really smart approach what you do in Hax, which is just to emit like new function bodies, because Aeneas already knows how to translate those into lean. Yeah. So then you're not starting from like nothing, right? And I think probably a simple prototype that we could try either remainder of today or tomorrow is macro expansion is recursive. So we could implement a small thin backend for anodized that just emits the Hax macro annotations, and then just piggyback on Hax from there. And then we would be able to see like, can we make this work? Like, where are the gaps? And then if we're unhappy with it for whatever reason, then we'll be able to iterate on it and like later refine it.
Yeah, but
I think to me, I'm already convinced that this is more modular and better structure than what we had, even though some of it we had also the loop invariant things but that's a good idea that we could engineer yours to, in the transition period, produce the Hax lib macros so that it works directly with the pipeline we already have, and at some point we remove this indirection and just directly get it the anodized methods, the anodized produced things.
And then with further improvement, we could explore is to actually extend the Karen to be aware of these. And then you basically don't have to do anything because Karen will.
Well, Karen is already aware of these in the sense that it already you can parse LLVC and you'll get that attributes.
Yep.
I mean, it's not doing it.
Just do some sort of annotation. So like you can say like, give me all the things that came from a spec annotation or whatever, or do the matching, like give you the IDs that you can match after the fact.
You start putting data invariants, then probably Karen will need to be aware of those because I'm not as just extra functions that have to be linked after Aeneas has finished the work.
Yeah,
it's something a bit deeper that you at every call site you have to make sure that at every use site you have to make sure that the value maintains invariance. So
I just meant something dumber, which is that the result of the Karen analysis, which is LLVC, already includes all of the attributes just as strings, right? But the point is that technically the information is there if you want to do it. So that I'm not,
that's the thing.
Can I sanity check that then if you had some analyzed annotations and you extracted to Hax, and then you also extracted to Verus to lean, they would look the same, or would they only be consistent up to some equivalence?
I think they would definitely not look the same.
Would it be possible to make them look the same?
Why do you think that's important?
Say you
do you mean like do the annotations look the same in Anodized, or the
when
stuff that's extracted?
Say I have a large Rust code base, and there's some stuff I'm going to deal with Aeneas, and there's some stuff I'm going to deal with Verus. But I would like the specs even for Verus, which are extracted to lean, to be consistent with the ones I'm getting in via Aeneas.
My hunch is that that's already not true. And it would
It's
probably
definitely
take
not true now.
yeah, so it would
but-
probably take a lot of effort and coordination between, because that's ultimately it's not like that happens due to differences in Verus and
Yes. And also because Verus treats the lean backend in a very different way than Aeneas treats the lean backend.
I'm honestly not knowledgeable enough about the like what happens, like what you all do in your respective tools, like in the bellows of Verus or Z3 or Lean or Aeneas, is like black magic to me. What really drives me is I just want to make sure this magic gets delivered to the Rust community so that everybody can benefit from it without like people like me who don't understand what's going on under the hood. Yeah, and I do worry that that's like a problem that people will expect. Like if we build an ecosystem where you can write, like one Rust crate can use, let's say Aeneas to formally verify itself and like export specs, and some other Rust crate uses Verus because that's their choice, and it also exports specs in some format, then these might not necessarily be compatible in the sense that they might use like fundamental different encodings of things like traits or I don't know, other non-trivial things. I don't know what to do about that, but I'm just assuming that there are probably solutions.
We did that in our work on TLS where we had several backends, and might be something to look at because they're I mean, you're looking for examples. But yeah, Alex, why do you think that they should agree?
It would be nice. No, but I think one reason is for example, so with Aeneas or Hax or whatever, you extract the lean and then you're going to do a bunch of proofs in lean, and you might prove something about your and have a spec where you written in lean and then prove something about your extracted code against these specs. With Verus, and I haven't played around with the lean back in Verus that much, so just entirely based on talking to Brian Parno close to a year ago, so things might have changed. So one is experimental, but two also the goal for them was never to do proofs about their programs in lean, they wanted the ability to reason about their specifications in Lean if they were complicated, but the proofs about the programs should also still be in Varus. And one thing that you might want is that you might have, for example, for our use case, we had some things where we wanted to try Varus on, but also there were things where, for example, if we're verifying some complicated cryptography, so Fry, where there's a significant proof in Fry, but also writing the spec for Fry is annoying, and I wouldn't want to write the spec for Fry in Varus. I want to write it in Lean. But I might want to verify some other parts of CompuStreet that feed into Fry. Let's say, whatever, filtrate or something, I could verify in Varus and feel comfortable doing. And I would like to have, if you want to kind of, something that feels like a single extraction that goes through different proof backends, was it directly in Lean, was it to Varus, and then still have some sense when I look at the Lean that the specs that I'm extracting from Varus and Aeneas are therefore kind of consistent with each other. And not that I'm kind of subtly actually checking different things by accident. Because there's still obviously, as long as there's some trusted stuff in the extraction, like I would like to be able to even eyeball check that I'm kind of being consistent if I'm using two different tools and not leaving gaps by accident. But then, but for now we don't really use Varus, but we actually have we do have one example of Willem from Sadik did some example proofs of some parts of the WASM ZKVM using Varus. Yeah. They took some of their rock proofs and then they ported them over to Varus and had quite a lot of automation, which was good. But then for things where maybe Varus got stuck, then it's you have this trying to deal with, okay, you have some stuff in rock, you have some stuff in Varus, and it quickly becomes hard to manage. And if you could get at least the specs to be consistent for both and Lean, it would add a bit of kind of both confidence, but also just nice UX and quality of life. But I have no idea how to make them look the same. As far as I understand, so like Varus is, at least I've had some feedback about Varus, which has been quite good, and I've had some feedback about Varus that you have like 3 IRs and it's like super messy, and I think that part of that was from the CVC5 people, which is probably why CVC5 doesn't work with Varus. And so it's hard to. I mean, it's always hard to gauge GSMT-based tools because you never know, like, if it's really good, and then suddenly you get stuck and it's harder to maybe debug, than in a proof resistant.
But even for Hax and Aeneas, I would expect different representation.
Yeah.